Hello. Hello, hello. We're getting ready to start our next talk. So I know there are lots of stimulating conversations about how to oxidize more of GNOME happening. But up next we have the first of two talks relating to JavaScript in GNOME. For this talk we will have Philip Comento and Sunny Piers giving it. Philip is the current main maintainer, I guess, of GJS, which is the JavaScript bindings for GNOME, and also a wielder of the big hammer, so to speak. He is my former GSOC mentor and a longtime JavaScript person within GNOME. Sunny has also been a contributor to JavaScript now for several years, bringing in exciting new ideas, specifically around, I think, incorporating web technologies and new ways to get newcomers involved in JavaScript for GNOME. So I'm very excited for this presentation, and I hope you all enjoy. Yeah, I will start the timer.
All right, I better get talking then. Thank you all for coming. This is a bit of a new way of presenting this talk. Like usually it's me running through some slides very fast, but yeah, so we, as Evan mentioned, we actually have 2 sessions now and 3 presenters, and we would have had 4. But yeah. So there's no shortage of talks about your favorite blazing fast memory safe language. So this talk is going to be me talking about new features that you can expect in, or that we're releasing in GNOME 44 and that you'll be able to expect in GNOME 45. And then Sunny will talk about some of the exciting community things that have happened over the past year. And then tomorrow, don't miss that one, you'll get Sunny again talking about tooling, and Evan talking about TypeScript. So yeah, you have all the JavaScript you could possibly want. So I'll get started on the new features. So as this part is going to be kind of similar to the other talks that I've given in previous years. I'll be talking about what's new and what's next. If you've been to this talk before in previous years, you probably know the format. This part is going to be aimed at people who write code for GNOME in JavaScript. So that could be inside GNOME shell, it could be apps, it could be shell extensions, it could even be command line scripts, because you can write those with GJS as well. GJS is GNOME's own JavaScript engine for these purposes. It's an extended version of the JavaScript engine from the Firefox browser, which is called SpiderMonkey. In past years, I've often included a section in the talk on various ways to modernize your code. But actually, nowadays, Firefox is running a pretty modern JavaScript, and therefore so are we. There's no long backlog of modern features to implement. So yeah, there's still some exciting new language features, but there's nothing earth-shaking like there was when we introduced ES6 classes. And also these days, thanks to the hard work of a lot of people on community, including my co-presenters and Sri and Andy, we have a lot more visibility for these improvements nowadays. We have better documentation, a more active community. Sunny will be talking about that. All right. As usual, this slide deck is also meant to be a resource that you can consult later. So there are links in it. Obviously, you can't click the links if you're watching it on the screen here or on the stream, but you can go to this address and view it yourself and click on the links. Right. So what do we see in GNOME 44 and 45? I'll use these little circled icons on each slide to show what version of GNOME this is appearing in. And if you see a hat emoji, that is me tipping my hat to the person who contributed it. Um, so one thing you might have noticed recently when we got top-level await is that if you started using top-level await dynamic imports and promises in your code, and it suddenly might freeze instead of completing an asynchronous I/O operation. This is actually not a new bug. It was already a trap, but it used to be very difficult to get into. But now that we have top-level await, it's a bit easier to accidentally fall into it. So it took a while to figure out what was going on here. At least once I ran into the problem myself in when I was porting an example app to use promise I/O operations. And I assumed that because the app froze, it was something wrong with the I/O operation, and I was calling it incorrectly. And it's not a quirk of how promises resolve in JavaScript. So I kind of shoved it mentally onto the I'll debug this later pile. But Evan actually identified the problem and found a workaround that could be used immediately, and also found a better solution that we released in GNOME 44. So here's some code. It's two files. One file dynamically imports another file. So what happens here, a dynamic import is a promise, at least to the JavaScript engine. It's an asynchronous operation. So launch.js imports main.js. Main.js launches an async file operation. That's also a promise. And so what it's supposed to happen is when the import promise resolves, then the file operation promise is next in the queue, and that's also supposed to resolve. But we have this line up here, this call to the run method, which, G main loop run, GTK main, all of those, G application run, all of those are blocking calls. So the import never finishes, and so the file operation is stuck forever because it's queued to finish after. It finishes, but it's queued to resolve after the import promise resolves. So that's kind of a limitation of how the JavaScript language is specified. Promises cannot resolve in a nested way. And the solution that Evan came up with is a very simple change in your code. You replace app.run with await app.run async. So what happens here is that we schedule the call to the main loop as its own promise, and that finishes when the blocking call is done, so it doesn't block the other promises from resolving. And so that way the module load can resolve, and then the other promises can resolve as well. So the guidelines for making sure that you don't fall into this trap in your app are very simple. Just always use await run async instead of run. Just always do that. I don't think there's any situation in which it's harmful to do that. So, but this is an evil trap for unsuspecting programmers like you and me, and we don't want those in our platform. So it would be great if we could have some sort of a linter rule that would just warn you not to call run. So that's a nice project if somebody feels like working on that. You'd help everybody in the community not freeze their apps. All right. We have loads and loads of performance improvements in GNOME 44 and 45, thanks to Marco over there. The biggest thing, to my great embarrassment, we were not actually properly using address sanitizer in our checking code for merge requests. So actually a bunch of merge requests got through that had memory leaks. Marco found this out and not only fixed the problem, but also fixed all of the memory leaks that had crept in. So thank you. And then, he's done loads more, but these were the two biggest ones. The other biggest one was these dramatic performance improvements in the legacy signals module, which is used a lot in GNOME Shell. So thank you. We are going to upgrade the JavaScript engine. We do usually at least once every year, we do an upgrade to the next long-term support release of the Firefox engine. So why we do this, it brings in newer editions of the JavaScript language, it brings in security updates, and we already have a pull request from Shiro Yao to upgrade to Firefox's ESR 115 version. And so I'll I'll talk a little bit about what are the new things that you can expect in that. And this is targeted for GNOME 45. Actually, all of the new things are array methods. And most of them are also on typed arrays. Not too many people use typed arrays, but these are arrays like uint8 array, int32 array. They exist. You can use them if you like, and they'll have these methods. Oh yeah, I put some array cats on the slide. Find last index. This is the first set of new methods. These are like find and find index, but they start at the end. These are kind of nice to have. If you didn't have them, you could write them yourself, but this, having them stops you from accidentally making an off by one error when you write them yourself, which is something that I would totally do. Here's an example of how you might use them. There's a new set of non-mutating array methods. So this is kind of new. This is not something that JavaScript has really had before. I don't actually know if everybody calls them non-mutating array methods. That's what I call them. The proposal to add them to JavaScript was originally called change array by copy, which is even more of a mouthful. But some of my colleagues at Igalia actually worked on this proposal, adding the methods to SpiderMonkey. That's a cool way that my day job intersects with my volunteer work for GNOME. Anyway, these four methods: to reverse, to sorted, to spliced, and with. So the first three, to reverse, to sorted, and to spliced, they are copying versions of reverse, sort, and splice. Those ones you may be familiar with because they're array methods that have been part of JavaScript for like 20 years or something. But instead of changing the original array, they make a copy and return it to you. So it's a different object. And then with is kind of the same thing, but instead of setting an element in the array. So instead of changing the original array, it makes a copy of the array with that element changed. So why do you want this? The motivation is kind of that this non-mutating style of programming has become more popular, mainly due to popular web frameworks such as React, but it can also affect GNOME. For example, if we can have a GObject with a property that is a JavaScript array, and GObject properties have notify signals, but if you mutate the array, you're not going to get a notify signal. So it's kind of dangerous to do a reverse, like in this code example here, on an array that's a GObject property. That might break an invariant of your program if you're expecting that you get a notification when the array changes. But if you use to reverse and reassign it to the property, then you'll get a notification. There's array from async. This can be used to build an array from the results of an asynchronous iterator. Now that's something that's also a fairly new JavaScript concept, but thanks to Sonny, we have one. You can create an async iterator from a GIO input stream, and that's iterators are not used that often, but I think in the coming years they will be used more commonly because in the standardization pipeline there are also more iterator helper methods which make this more and more attractive programming pattern to use. So you could do this with a for await loop before, but using this method is a bit more efficient because pushing each value into the array happens inside the JavaScript engine instead of in your code. Here's something that I really hope that we can land for GNOME 45, native async operations. This has been a really long-awaited feature. I'm sure everybody's heard me talking about it year after year. 2 outreachy interns have worked on pieces of it already, and Evan is now working on tying it all together. This is kind of an example of how you have to do something the old callback-based way. This is affectionately called the pyramid of doom because you have level after level after level of indentation and then have to unindent it all. So yeah, this is just two async operations chained after each other. So imagine if you had to chain 5 of them or something. That's where we get the pyramid of doom from. But the current way to do this, with the improvements from our previous outreachy internships, is for each method you can opt in to making it return a promise using an unofficial function that is a technology preview called _promesify. And once you do that, you can use await with these methods, and they'll return promises so that you can use await on them, and you don't have to pass callback parameters. So this was from Avi's internship in 2018. We've had it a long time already. People use it. So we're looking forward to making it official. So really, all we want to do is just the same thing, only you don't have to opt in for each method. It just works. And you could just comment out or delete these _promesify lines. So what the _promesify does is tie the start and finish functions together, and it relies on you, the programmer, to provide that information. Like what's the async function, what's the finish function? In order for it to be done automatically, we need to get that information from GObject introspection annotations. And as a result of Vina's internship in 2021, we have a merge request that adds those annotations, and it can put that information into the GIR files, which we load in GJS. And Evan has most recently worked on a C API so that we can access those annotations from GJS. And then the last bit left to do is to use that API in GJS, which there's also a draft for. So it's getting very close, GNOME 45. Another feature it's possible we might get for GNOME 45 is import maps. This still needs a bit of discussion of how exactly it would work and how it might be used. So we're looking for input on this. Import maps is originally a web feature. So there's a link on this slide to the HTML spec for import maps. But here's approximately how it works. So if you're importing something in JavaScript, you might know that you can't import what is called a bare word. So all imports either have to be a URL or a relative path, like starting, for example, with ./myfile.js. Bare word modules are reserved. The environment can provide them. So we do that. In GJS, we provide a built-in bare word module called system, which has system stuff on it, along with a few others. But if you try to import a bare word that we don't provide, you get an import error. So you can't just import foo. But with import maps, you can tell the environment that you want to map bare words to URLs or relative paths. And this is a separate JSON file, and you provide it to GJS when you start the interpreter. So GJS then makes those bare word modules available to your program, and behind the scenes it redirects it to the address that you give. So here, if you want foo to refer to a JavaScript file in your G resource, you can provide this import map, and then this code down here, import foo from foo, then it goes into your G resource and it imports that file. So this, if I describe it like this, it's also kind of, yeah, okay, that's neat, but why would I want to do this? So some use cases could be to define all the API versions of your platform libraries in one place. So in our guidelines, we do actually have a recommendation for apps that you define these in your entry point, like add the little version tags to your GI imports so that you don't accidentally import more than one version. But putting it in one of your JavaScript files is kind of arbitrary. So maybe defining them in an import map makes more sense. And you could even use this to implement multi-version support. If your app, for example, could work with GTK3 or GTK4, you could give it a different import map depending on what you wanted to import. Or import a library if it's present on the system, and import a shim if the library isn't present on the system. You can do this now, but you have to use dynamic imports for that. That's kind of a pain. Another thing could be to implement something like Node.js module resolving, where you can import a bare word and it'll look for that module in your node modules directory. So your build tools might generate an import map like this. If you import Lodash, and then you can have a tool statically analyze your file and say, oh, Lodash, let's look in the node modules directory and write that in the import map. Another thing, I won't talk too long about this because Sony might talk about this tomorrow, but you could also have your, you could also import something from an online URL and have your build tools download and cache that and write that in an import map. But you might also use gResource for this in your build system. So there's more than one way to do this. So yeah, what we'd be interested in knowing is, would you be interested in using this? And what use case? What would you use it for? So we still have some questions to answer, but yeah, we'd love to hear from you about this. A bit farther in the future than 45, it looks like decorators are finally coming to JavaScript. Maybe in the next SpiderMonkey version after this one, we're not entirely sure, but there's some signs. So this is something that we've been planning for a long time, is writing your GObject classes with decorators, like you can do in PyGObject. It's really convenient. It's a more expressive replacement than using GObject.registerClass on everything. So we need to figure out the shape of this API. Would you use it if it existed, and what would you like it to look like if it existed? So let us know that as well. All right, about the big hammer, I'll give a short status update. If you want all the details, watch my talk from a few years ago at GUADEC 2019. So yeah, quick summary. This was an issue with the garbage collector in GJS holding on to objects longer than it should have because of the way that JavaScript objects and GObjects referencing each other can lead to sort of circular references. We have a workaround, thanks to Georges, called affectionately the big hammer that runs the garbage collector every 10 seconds to clean up these objects. Running the garbage collector every 10 seconds is obviously bad for performance. We've had a fix mostly finished for several years, but the problem is that if we merge it, then counterintuitively, GNOME Shell's memory usage will go up again because we're no longer over-collecting the garbage. And users do watch this stuff. And so if we do that without some sort of, way to quantitatively measure the benefit and also some clear messaging, then it can, it has the potential to turn into a public relations disaster with all sorts of articles published complaining about memory leaks and GNOME using more and more memory. So yeah, the only problems left to solve here are squishy, demotivating problems where it's not clear what success looks like. So we really need some help with those. There are also some coding tasks, but I feel pretty confident that those will get done. But yeah, if you can help measure and quantify the effect of the fix on GNOME Shell's performance and help figure out, like, is it actually better for users and how can we tweak it so that we make sure that it's better? If we have some numbers that are not just somebody running top and looking at the RSS size, which is what internet commenters generally do, so that we can sort of effectively show that this is a benefit, then that would be great. We really need that, and we really need help with a communication plan for when we merge it, so that we can figure out how to set expectations for users who have been awaiting this for a long time. So we'd love some help. And at this point, I'm going to turn it over to my co-presenter.
Hello. Oh, yeah. Okay, it's a bit intimidating to go after Philip, but yeah, and a great presentation. But I'll try my best. Right. So I'm gonna talk about. I think I'm too tall for this. Can you hear? Yeah, it's good. Okay. I'm gonna talk about the community aspect of the GNOME JavaScript project. There's a lot to talk about. There's documentation, There is extensions and so on, but those have been talked about quite a lot in the past. I'm going to focus on just a couple of things, and right now I'm going to focus on apps. We've seen a growing number of apps targeting GNOME JavaScript. Full disclosure, a third of these are mine. So of course that helps, but then I realized that people started building apps with GNOME JavaScript because I had made examples of how to do that and just copy-pasted the code, which is wonderful. What I find interesting in this list is that it's been used for very different use cases. There's, for example, Clapper, which is a video player. It uses GNOME JavaScript for the UI. I think it's a good way to iterate quickly on the UI, right? Because it's just so low maintenance with JavaScript, very easy. And then they use C and GStreamer for the backend. There is this design tool. Oh, but I have a slide about that. Give me a second. There is Foliet, which is a very popular by now ebook reader that's been also around for a while. There's an app written in ClojureScript. So in Clojure, compiled to JavaScript, run inside GJS, which is interesting. There's been some movement also in TypeScript. We'll talk about this, or Evan will talk about this tomorrow. There is GNOME Maps, of course, which uses JavaScript for something that it wasn't really made for. It's a very interesting use case. Yeah, it's also used in very different ways. Some apps, they embed GNOME JavaScript, and then they start it from C or from C, like Polari does this. And then there's some apps that loads C libraries from using G-object introspection from JavaScript. So there's all sorts of ways that JavaScript is being used right now in those apps, and I'm quite excited about what's going to come next. One use case I mentioned is this this app by Daniel Wood, which I thought was really interesting. They made a 2D. I don't know anything about this domain, so I hope I'm not saying anything wrong. But they made a 2D CAD design app. This is the PCB of the Raspberry Pi, and this is all interactive, right? It's not just for viewing. You can also like draw components, I guess, or circuits. Yeah, I really don't know anything about this. And I was really impressed with this work. So I got in touch with Daniel and I asked them why they use GNOME JavaScript. And they told me the history of the project. It started as an Ubuntu and Ubuntu phone app written in C++, QML, and JavaScript. I think they work in this domain professionally, and they wanted to have something sort of that would work also on phones for some reason. Maybe they do spend a lot of time doing 2D CAD in the subway, I don't know. But whatever, it's cool. I find it really nice. And then Ubuntu phone got like sort of cancelled, and they thought, okay, what am I going to do with this? I have a bit of JavaScript. Oh, and I think by now they had already ported the whole like parser for this format and rendering engine from C++ to JavaScript, because they figured, okay, it's fast enough. I actually don't need to use C++ for this. And yeah, right, so Ubuntu phone got cancelled, and then they thought, hey, I'm just going to turn this into a web app. Because they had the JavaScript, all the complexity, the backend written in JavaScript anyway. And I think then they got excited about GNOME progress on the platform, and they thought, okay, now I'm going to make a GNOME app out of this. And because they already had the whole backend written in JavaScript, it was a natural choice to use GNOME JavaScript. Yeah, give it a try. It's fun. It runs really well. And I like this example and this story because it shows why it's important to have like a broad range of support for languages in GNOME, and not like fight about which programming language is best, but rather like provide as much as we can and then get people into the GNOME project by, because their favorite language is JavaScript or TypeScript or C or Rust or whatever. Yeah. Yeah, this is a bit controversial. It's not about, I'm not telling people not to do extensions, but I looked at the list of like the most popular extension for GNOME Shell, and a lot of them could be apps. And I think the reason why extensions are so popular still, it's because they're very easy to make. They're very easy to iterate on, or at least they were on X11. Now it's a bit harder, but and they're very easy to distribute. And I want to tell people who make extension, hey, now thanks to GNOME Builder and Flatpak and FlatHub, it's also very easy to make apps. So I encourage you to give it a try. You can, you can use GNOME Builder, select Create Project, choose JavaScript, and you have a pretty nice template to start with. Yeah. There's also, I'm going to go a bit more into like people and community right now. Before I do that, I need to introduce Workbench quickly and describe what it is. It's an app that I and other several contributors, such as Lorenz, is building. To put it simply, it's a sandbox for GNOME development. So you have a bunch of code on the left, a bit of GTK in the middle, and then you have real-time preview on the right. And it's, yeah, I'll talk more about this tomorrow. I don't want to go too much into details now. You should come to the talk tomorrow. But yeah, the reason I'm introducing this is because I want to talk about Workbenchers. Workbench Summer 2023. It's sort of a team composed of 2 mentors, I and Andy, 2 GSOC students and 1 Outreachy students, which are in the room. But you can see them here, Akshay and Sriyansh. Oh, this is not centered. That's okay. Yeah, they've been working with me and Andy for a couple of months now, adding, oh yeah, something I forgot to mention. There's a library on the top left corner of Workbench with a lot of demo and examples of what you can do with GNOME JavaScript or GTK in general, but also Vala. We also introduced, Lorenz introduced Vala support recently. Yeah, we've been working with these 2 amazing GSOC students this summer to add support to add a large number of demo to showcase the platform. It's similar to GTK demo, except it's more inspired by the Hague and how to do like specific patterns that the GNOME design team encourages and so on. It also demonstrates how to use libportal APIs for Flatpak and yeah, many other things. And there was also Jose, who is not here today, but this is a screenshot of that one time Jose managed to finish his camera demo using libportal and GStreamer GL sync bin, and I think it took him a week because there was a lot of complexity with pipewire and so on. And he was just so happy. He sent us this screenshot. Yeah, it was. Yeah, it's a very nice adventure. It's still ongoing. We still have until I don't know 1.5 months or something ongoing. Our objective is to reach 100 demos in Workbench. These are not trivial demos, right? We pay a lot of attention to design, that the code is easy to read, that we demonstrate the right thing, that we don't demonstrate too much. Yeah, so I'm very excited. It's been going great, and I'd like to thank Andy Holmes for helping me mentoring. It sounds like Rust is a big topic this year, so I added a last-minute slide about Rust. Rust and JJS. This is not about, how do you say, introducing Rust in JJS, but rather I just wanted to showcase this cool example by Xander Brown, which shows how to use essentially Rust and JavaScript into your app. In the case that maybe you want to do the backend in Rust and just use like the JavaScript for the UI because it lets you iterate very quickly. Yeah. This is 2 years old already, but I think it's been under the radar a little bit. So I just wanted to showcase it. It's great. Have a look. Yeah, and another community project by Christian Herget is JavaScript support in libpeas. So libpeas is a G-object-based plugin engine targeted at giving applications a chance to assume their own extensibility. So you take libpeas, you put it in your app, and then you do a bit of magic and glue code, and all of a sudden your app can support extensions. Don't do this in every app, please. there's very specific use case for this, but one, of course, is GNOME Builder is using libps for plugin. So thanks to Christian and Philip, we can now write JavaScript plugins for application and JavaScript plugins for GNOME Builder. You want to do the? Yeah, please do the conclusion.
Okay. All right. Well, that was the end. We'll have time for questions, but yeah, we'd especially like to thank Nasakuma for joining in with the ideas for this talk and submitting it along with us. But unfortunately, she couldn't be here to present. But hopefully next year. A big thank you as well to everyone who helped in any way with GJS and the JavaScript community in GNOME 44 and 45. Thank you so much, everyone. There's a license for this slide deck. You can reuse bits as is with attribution and not for commercial use. And it's time for questions. You want to come share the microphone for the questions?
Hello, this is, yeah. Regarding testing the branch and that will remove the big hammer, is there a version of the branch that is rebased and working right now? Because that would be super helpful for helping you. Yeah.
I need to rebase it. I'm sorry.
But you will, and you...
Yes, especially if somebody says, "Hey, if you rebase this, I'll work on testing it."
Cool, thank you.
Hello. Do you plan on starting using dogs for our next presentations too? Okay,
We concur on no.
that's unfair. Okay.
First, thank you so much for the nice presentation. I haven't looked too closely into writing apps with GJS yet, but as far as I understood it, if you write the application with that, then you cannot just tap into the vast ecosystem of Node.js. You're limited mostly to, I don't know, C libraries with a G-object introspection exposed, right? Like this is the first half of the question. Is this true so far?
Is your question whether you can tap into NPM? Or
Yeah, for example. If the answer is you can, then I don't have a second question.
No, you definitely can. I've been doing this for a while. I need to document how to do this because unless you're a web JavaScript expert, it's hard to figure it out. So there's been more and more different JavaScript engine coming. There's a lot of competition in there, not just engine actually, but runtimes. So we have Node.js that we know well by now, but there's also Bun and Dino. And they don't have the exact same APIs because those runtime APIs, except for web ones, they're not standardized. Mm-hmm. So what's been happening is the JavaScript community has been pushing towards building libraries that are runtime independent. And so it's great news for us because it means there's more and more libraries on NPM or wherever else that we can use in JJS. I started compiling a list of things that works almost out of the box, but also I've been working on a polyfill project to polyfill some of the most standard JavaScript APIs so that people would be able to use those libraries on JJS without downloading hundreds and hundreds of node dependencies. I will maybe talk about this a bit more tomorrow. Maybe Evan also wants to add something.
Yeah, it's awesome to hear. Thanks a lot. Of all of these apps that you showed before that are using GJS, does one of them already take advantage of that?
Yes. For example, Workbench uses Prettier for auto formatting. I didn't make any modification to it. I just download Prettier. It's a plugin that reformats code. It's written in JavaScript. It supports everything we need, so that's why we've been using it. There's also this application, Forge Sparkles, I believe it is. The one with the nice icon in the middle here. It uses a fetch polyfill, so it uses the web fetch API, which in turn use libsoup to do HTTP requests with a very nice API that web developers are used to. Yeah.
Nice.
So we've just hit time, but we do have a break up next. So if there's any final questions, I think we're happy to field them. Anyone? Well, thank you all for coming. Part 2 of the JavaScript talks will be tomorrow, I think also in this room around a similar time, but check your GUADEC schedule. And we have about a 10-minute break now, I believe. And then up next we will have, another JavaScript-esque talk, The State of the Shell by Carlos.